Today, we're going to be talking about the breakthroughs in personalized health. This is going to be an insider's look behind the scenes at the newest research and the latest technology advances that fundamentally enable these breakthroughs. We're going to talk about 3 topics. First, we're going to look at diet. We're going to go to Stanford University and see the latest research in how foods impact you. The research says that maybe a few simple adjustments, you can slow down your aging. Then we're going to look at exercise. We're going to look at a new sensor in development that also promises that kind of specific physiology-based outcome for you. And then finally, we're going to talk about the enabling breakthroughs in electronics with experts at Infineon who are working on exactly that. They'll tell us what they're working on and where they're going. My name is Adrian Mikołajczyk, and I run Infineon's Silicon Valley Innovation Center, and I love my job. It gives me a unique opportunity to go behind the scenes and see the technologies not yet public that could impact your future. So let's get started. To learn about the latest research in personalized health and diet, we met with genetics expert Dr. Michael Synder at Stanford University.
Personalized health is all about keeping us healthy, and it's all done at an individual level. It turns out we're all different, and the way we respond to food, the way we respond to exercise, it is all very individualized. And an area we study a lot is actually glucose dysregulation. So it turns out if you put these continuous glucose monitors on people, they'll measure glucose every 5 minutes. You'll have some people who will spike to bananas, other people who will spike to pasta, others to white bread, others to brown bread, some to potatoes. It's all over the map, and it's not clear what's causing that. The microbiome, meaning the guts, the microbes in your gut, account for some of that, but most of it's unexplained. You need to understand these responses in order to maximize your health. You want to keep your glucose, if you can, pretty steady. It's what underlies type 2 diabetes. And this is true for everyone. The grape spikes are fast. Grapes are like sugar. They go right into you. Whereas you'll see potatoes tend to spread out. They're more complex. So does rice, actually, for that matter. Probably has complex carbs that spread out the signal, the glucose response. Turns out a lot of normal people and pre-diabetics are actually pretty dysregulated too, some quite severely. And these glucose monitors let you pick that up. And then to discover which foods spike you is a big deal because we think you want to avoid foods that spike you and eat those that don't. And then the other thing we're doing now is we're having people eat foods before they eat rice, because most people spike to rice, and then we see what foods will suppress their rice spikes.
So now you start working on the order of food and how that optimizes or minimizes the negative impacts of glucose spikes.
Yep, and it's very personal. If I want to measure insulin resistance by today's gold star assays, it's probably $4,000 to $6,000 a patient. There's some other like oral glucose tolerance tests. They're cheaper, but they're still probably at least hundreds, if not $1,000. It turns out though, with these new continuous glucose monitors, you can take a simple glucose shot, if you will, at home, and actually from the shape of the curve, we can predict what kind of diabetic subphenotype you are. That's using AI. So just from the shape of the curve, we can actually tell to some extent what's wrong with you. And knowing what's wrong with you can help tell you what food you should and shouldn't eat. We're not there yet. We're working on a lot of this. And this is your typical wet bench lab. If you ever wear a glucose monitor, you'll never eat the same because you'll see exactly what spikes you, what doesn't, and then you just eat more of the things that don't spike you but you like, and you avoid those that do spike you. Sometimes that's a little hard to give up, but if you are going to eat one of those things, well then you do a 15-minute brisk walk and you can actually suppress that spike.
We literally flow through individual DNA molecules.
We believe the benefit of personalized health is to extend your health span. So the difference between our health span and our lifespan is 11 to 15 years, depends how you measure it. And so the goal was really to extend people's health span all the way out to the lifespan. You'll probably extend their lifespan a little bit in the process too. So we don't want people living the last decade of their life living unhealthy. That's the goal. It's to really know what's going on, to modify your behavior to stay healthy.
We recently traveled to San Diego to meet with Jeff Surrey, a renowned sensor expert and research scientist. He designed and is currently conducting experiments with a new sensor technology to track your personal lactate levels continuously. We also met up with Richard Sweet, who twice won the 55 to 59 age group in the Kona, Hawaii Ironman. He's also experimenting with this new sensor to streamline his own training and take it to the next level.
Glucose monitoring, you look at the food that you eat every day and how high the food makes you go up and down. With lactate, you're looking at your exercise intensity. A lot of times you think that going harder is beneficial, but your lactate tells you otherwise. If your lactate goes too high and it doesn't come back down, then you're actually doing more harm than good for your workout routine.
Lactate sensors have been around for decades, and there's a lot of insight into the lactate molecule and what it really means for metabolic health. So in specific to athletics, we know that high lactate levels are indicative of your effort and what muscle groups you're actually recruiting to do an activity. So in the case of biking, I might look at lactate levels in a steady state around 2 millimolar. But as we stand here today, you can see my baseline or my resting lactate. So there'll be some effort to get it up to 2. And so that would be what we call lactate threshold 1. If you increase the effort and go to the next threshold, which they call lactate threshold 2, around 4 millimolars and change, that's anaerobic.
It has been established that with a lactate meter, you can look at your exercise intensity. If someone like a technician is next to you measuring every 3 minutes, taking a blood sample, and that blood sample will give you a number. But if you wanted to monitor throughout your whole exercise routine, running up a hill, riding your bike out in the field, there's no way to do that with a meter. You need an actual wearable to understand what your levels are at. These are fingerstick measurements going from about a 2 millimolar concentration of lactate up to about 8 and then back down again. So with a continuous measurement system, you're able to fill in all the gaps between those points. So you can actually now observe your first metabolic threshold, your increase in intensity, and then your peak, whereas these single points did not capture all that detail.
This is a lactate sensor. You can see here it's a prototype.
You can see it through your shirt.
And from there, we've also developed Garmin apps, Garmin IQ here. So while I'm cycling, I can actually look at my lactate levels, my heart rate, my power, my cadence. So I can go back and look at my data on Garmin Connect. I can go to other online data analytics systems, which I use, where I can really look at the whole picture of the ride. There's really nothing like this out there to allow you to get continuous data across your 24/7 lifestyle right now.
So this is our prototype sensor.
Yep.
The housing is a little bit large right now, but it holds a sensor that ends up under your skin and measures your lactate directly. We've been collecting data in different environments, so running, riding a bike, surfing, and I would highlight surfing because usually you can't measure surfing with a sweat sensor. If it's under the skin and waterproof, now you can go in the water and look at water sports. This represents my workout during the surf. As you approach the waves from the beach, you have to paddle quickly depending on how big the surf is. The intensity at which your lactate increases or it gets to, the level it gets to, is sort of representative of how big the surf was that day. And then once you're out there, the recovery in a way is sitting on your surfboard waiting for the next wave. And then the little peaks that you see up and down here in a way are like each wave that comes through in a set. And so it's giving you almost a wave counter depending on how good the day was. I think lactate has the power from a consumer standpoint to improve overall health. You can hit any exercise intensity and watch the actual recovery of your physiology in real time. And depending on how long that takes or what that path looks like, the next time you go to do an exercise, you might back off and not be as intense, or you might be more intense. Either way, you're sort of able to act like an athlete even though you're just a consumer, because now you have a tool that enables you to be smarter about the way you exercise.
Now I want to dive one level deeper into the semiconductors that enable this technology. Making this stuff work is not easy. So I talked with an engineer and a product definer here at Infineon to give us that inside scoop around working with these types of sensors and then what they believe their work can enable in the future.
Health and Bluetooth go hand in hand for a very long time. Infineon is working with a lot of scientists and R&D personnel to take it to the next level. Ideally, when you look at a current lactate sensing solution or a glucose sensing solution, you have a sensor, then you have an MCU, and then you have connectivity. There has been a requirement to combine compute and connectivity together, which we are leading the industry in. There has also been requests that, hey, can we do algorithms? Can we also add sensor fusion? Can we add sensor capability as well? So Infineon is looking at all of those things and trying to provide a complete end-to-end solution to the customer.
I'm holding a reference design for a wearable continuous glucose and lactate sensing system. It measures these analytes and lets you track the value on your phone or watch. To enable it, we solved a really hard problem of measuring sub-nanoamp currents with single-digit picoamp noise level. I can tell you that's a big deal in the industry, and not many people can do that, especially given the cost, size, and power requirements of these kinds of wearables. It has to last 2 weeks on a single coin cell. We achieved that.
Bluetooth as a protocol allows you to do different kinds of connectivity networks. So you could have a single Bluetooth chip talk to another phone or a device. You could have two Bluetooth chips talk together. You could have up to 10,000 talking together if it's a large installment. When it comes to health and fitness, you could enable people to have various readings, all of them put together in one single application that is available for the healthcare provider to give you the best guidance.
I hope you enjoyed this exploration into personalized health. I definitely took it to heart. In fact, I bought myself and my wife a glucose monitor so we could just go deeper into this topic. If you want to go deeper on the topic, or you want to suggest a future topic, check out the included links. We'll see you next time. Stay innovative.